Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can divide with complex numbers on the bottom. So just like with radicals, we don't want to have complex numbers on the bottom because they're kind of icky. So we want to learn how we can move them out of the bottom. Now, remember that when we learned how to multiply, we learned that I squared is equal to -1. So what we want to do is anywhere there's an I want to turn it into an I squared, so we get rid of it. It's just like a little flashback to the beginning of the chapter when we had a square root in the bottom. And remember how we multiplied this by a special form of 1, which was whatever was on the bottom here. And the reason why we did that is because we wanted to get rid of this square root. And the square root of 7 squared is the same thing as the square root of 49, which is just 7. And so we want to get rid of that square root in the bottom. And we did it by multiplying by a special form of 1, which was exactly the same as what was on the bottom. Now we want to do, and then we multiplied across. So we got 3 root 7 over 7. Does this sound familiar? Well, we're going to do the exact same thing when we're dividing with imaginary numbers on the bottom. So I want to get rid of that complex number on the bottom. And I'm going to do that by multiplying by a special form of 1 that's going to look exactly like our base here. So I'm going to do 2i over 2i. And as we multiply these, I end up getting 6i on top. 2 times 2 is 4, and we end up with an I squared. So remember, I squared is the same as -1. This is our key here. So we end up getting 6i over 4 times -1, or 6i over -4. And we can simplify that, of course, to 3i over -2, or you can leave your answer as it was up above. But that's how we're going to divide. We're going to multiply by a special form of 1 that looks exactly like the denominator. Now, this is the case if we have a complex number that only has an imaginary part. If we have a complex number with both a real and an imaginary part, we're going to do something different, and we're going to talk about that in the next slide. But for right now, let's practice what we do when we divide by just an imaginary number, by a number with only that imaginary part. And again, we're just going to multiply it by the special form of 1 that looks exactly the same as the denominator of what we're dividing by. So so we're going to multiply by -6i divided by -6i, and that gives us a -30i over, well, -6 times -6 is 36i squared. Well, then I'm going to move this so that we have more space. Then this is going to end up equaling -30i, and then 36, but we know I squared is actually -1. So then we multiply this one more time, and we end up getting -30i over -36. And then we can reduce this or simplify our fraction, and we end up getting 5i over 6. And that looks a lot prettier than 5 over -6i, does it not? So I want you to try this next one on your own. So I'm going to scroll down a little bit. We are going to do this 4 divided by 7i. So go ahead and pause the video. Try multiplying this one out. When you've finished, unpause the video and we'll go over it all together. Okay, hopefully you've had a chance to work through this problem. So again, remember, we're going to multiply by our special form of 1. In this case, it's going to be 7i over 7i. And as we multiply that, we get 4 times 7, which is 28i, divided by 7 times 7, which is 49. I times I, which is I squared. Now again, remember, I squared is the same as -1. So really we have 28i over 49 times -1, or 28i over -49. Now 28 and 49 have a common factor of 7, so we can divide by 7 on the top and the bottom, and this simplifies to -4i over 7. Now notice how our negative sign moved up. It can stay down or up, depends on what you prefer. I prefer to have my negative sign on top. So the only other type of dividing that we need to look at, so these ones have all had just an imaginary portion. In these next 2 examples, we have complex numbers on the bottom. So they have both a real and an imaginary portion. The way we are going to simplify this is just like we did when we were simplifying radicals. Now remember, when we simplified radicals, we had to multiply by what was called the conjugate, which means it's the same number here, the opposite sign, and then the same number here. And we want to multiply that in a special form of 1. And then what we do is we end up multiplying the top and the bottom. So we get 3 root 7 minus 15 over, well, 7 root 7 is 7, minus 5 root 7 plus 5 root 7 minus 25. And then this ended up being 3 root 7 minus 15 over 7 minus 25. Well, 7 minus 25 is the same thing as negative 18. So this became 3 root 7 minus 15 over negative 18. They all have a common factor of 3. So this is root 7 minus 5 over negative 6. Fantastic. We are going to do the exact same thing when we have a complex base. We're going to multiply by the conjugate complex number. So we are going to multiply by same, opposite side, same, and it's got to be 1. So whatever's on the bottom goes on top, and then we'll multiply this. So let's multiply our top. 3 times 2 is 6 plus 15i over 2 times 2, which is 4, minus 10i plus 10i minus 25i squared. Now notice that I just FOILed here. I went like this to get those numbers. Now we want to simplify this, so I get 6 plus 15i over 4. Well, minus 10i plus 10i cancels. Minus 25, and I squared is the same thing as negative 1. So we end up getting 6 plus 15i over 4. Negative 25 times negative 1 is actually plus 25. So this simplifies into 6 plus 15i over 29. And because 29 is prime, this is as simplified as it gets. So that is kind of what we're doing here when we are dividing, is we want to follow that same process. So let's do one more example like this. Again, we're going to multiply by our conjugate. So our conjugate, again, is going to be the first number, opposite sign, the second number, and it needs to be that in the form of 1. So then as we multiply these, we end up getting negative 5i plus 15i squared over 1 minus 3i plus 3i minus 9i squared. And then we have lots to simplify here. So our negative 5i plus 15 times negative 1 over 1, these two cancel, minus 9 times negative 1. So then we end up getting negative 5i minus 15 over 1 plus 9, which is 8. So our division ends up simplifying to negative 5i minus 15 over 8. Now 8, 5, and 15 do not have a common factor, so that's as simple as it gets. So these properties on numbers are very similar to the properties on radicals. If you know one, you know the other. And this is how you would get rid of a complex number that might be in the base. Again, when we're talking about complex numbers, that means they have an imaginary component in the bottom. Of course, it's okay to have just a real number in the bottom. That's really what we're seeking to get. If you have any other questions, feel free to reach out, but this is kind of the rundown on complex numbers, what they are, and how we do basic operations with them.